So, okay, Vance.
So
So, do you want the 5 minutes or you want to? Okay, we start.
I'm good. I just want to explain what's going on. It's
Okay.
Wednesday my time, and somehow when I saw the meeting is on Thursday, I forgot that you're a day ahead of us.
Yeah,
So
we are on the other side of the world. Yeah.
so
So,
I'm driving down to LA because I'm meeting with uh Nafumi, who was the ex president of Sony running the studios down here in LA,
right.
and they're going to make a video of for business of
All
how
right.
this pump actually works.
All right.
So that's
So,
what the meeting tomorrow is all about.
all right, friends. So let me introduce. Okay. Let me mediate this meeting. So, this is Gordon Hosking from Australia. He's in Sydney, sitting there. Gordon, say hi.
G'day, Vance. How
So,
are ya?
so
Hey
Gordon,
guys.
so Gordon and I, we have some venture together, and Gordon is a what you might call the money guy. He's very connected to many venture capitals in
Yep,
Australia, Singapore, and Malaysia. And
yep.
I talked to Gordon about your inventions and about that you are about less than a year into making the prototype commercial or ready, and you need at least $10 million to finish up the commercial prototypes and then ready to be mass produced. Is that correct, fans? Right?
Yes,
All right.
yes.
So
I
having
have
said,
I
wait.
have my other guy. I have my other guy, Sabash, that was supposed to be on this call. Now, Sabash is a distinguished lecturer on artificial pump, which means that
Okay.
he's an expert on pumps.
All
So
right.
he works for Occidental Petroleum and is responsible for all the offshore drilling.
All right. So very good.
So so if I
Fans.
can pause for a second, I can get him on the call.
Okay, very good. So do you want like 5 minutes to get him on the
Just
call?
I'm just going to reach out to him. I'm going to put you on hold and just reach out to him.
All right, very good.
Okay, hold on.
We'll wait. Always happen like that. When you're doing,
Yeah,
communicating with the US, they always thought they are in the same the same day.
yeah, no problem. It's all good.
Right.
Uh,
So it's kind of hot down there now, Gordon.
yeah, well, it's a nice day today, but the evenings have been a bit cool, which has been a bit unusual for this time of the year. Um, it's really strange. We've had a very late winter. Spring
Okay.
is generally this time. We're almost now, 1 month into spring. So by now, people are already in the swimming pool, but I wouldn't be going near the pool at the moment. It's freezing.
So what's the temperature now? I mean, just preparing for my clothes.
That's a good question. It's about 20 to 22. Let's have a look. Oh, 23. Wasn't far off.
Celsius. Celsius. That's
Yes,
quite cool. That's quite
degrees
cool.
Celsius. Yeah,
Yeah.
it's 20. Actually, we are 24, it says,
And
but
fans. So we are all set, fans.
Yep, Sabash is getting on now.
All right, very good. So let me introduce Vance Gordon. So this is Vance Turner. So I met him about 3 years ago. He's an inventor. Used to work for NASA, right, Vance? And
I
Vance.
I did the I was part of the team that put the numerical aerodynamics simulator back in at NASA in the early time, and it was the fastest computer network at the time, and now it's in the bottom 500 realm. But look at all the things that it's completely changed.
All right.
Everything about hypersonics.
So why I'm interested in this, because fans develop or invent a very revolutionary kind of a pump, what they call the pulse detonation pump. I think that's your
Yep,
guy, right? Okay,
yep.
Subas, right? So a pulse detonation pump 3 years ago, and now he's I promise to help him. And at that time, I was quite busy on my plate with Forcon. Now I'm resigned, so I have more time, and I'm going to help him develop or find funding for his prototype for to be commercial. I think it is a breakthrough. So having said that, Vance, why don't you explain a little bit about your invention, about the technology? Hi, Subhan. How you doing? I'm Bob, and over there is Gordon from
Good
Australia.
day. Good day, Sebash. How are you?
Right,
Yeah, you're on mute, I think.
right. So, Vance,
Well,
having
thank
said
you.
that,
How are you guys? Yes.
why don't you explain in a short what is your technology and the status of your design of the prototype? Please, Vance, go ahead.
So Gordon, what do you understand about the pump now? So that I have
Well,
a
to be honest,
baseline of it.
very high level. At the end of the day, I haven't really gone into the great lot of detail. As Bob mentioned, I'm more the commercial money M&A guy. So, but
Okay.
incidentally, my family they're involved in engineering. I come from a long line of mechanical and hydraulics engineers. So my family are heavily involved in the mining space and supplying the mines with all sorts of equipment. But I'm not.
Okay.
I never went down that path. I went down the different path.
Of course you did. It's like my family. My family was my father was a VP for General Electric when they had a division for heating and air conditioning.
Wow,
So,
there you have it. Well, that's
but
great. Look, I've heard a lot about it. Look, I know a little bit. I did study, a bit in uni and did a bit on physics and chemistry, and I'm involved in small modular reactors in the nuclear industry,
okay.
all sorts of things. So I can pick up things pretty quickly. So
All right.
Yep, that
I'll
helps
leave it
me
to
out.
you to maybe intro.
Yeah,
Okay,
that
Vance,
helps
go
me out a
ahead.
lot. So what we've invented is a pump. And in this pump, down there in Australia, there's the Humphreys pump that was in a district to do water. And they were using wood gas to basically do a detonation pump. So that was and when they invented that detonation pump, it was more efficient than anybody had at that time. So it was a very successful device that they built down there, and they ran it off of wood gas. But detonation pumps never really got a start. But in that, what we're building is a detonation pump that expressly uses hydrogen and oxygen gas. And in using hydrogen and oxygen gas, we've actually developed a new work cycle. So you know that there's the Carnot cycle and the Brayton cycle, all those the FJ detonation cycle, you know, those are all the current work cycles that are built off Carnot. This pump, though, invents a new work cycle where all work cycles that we have right now are
Yeah,
basically 4 cycles. And it has to do with the thermodynamics that are in play.
yeah,
Well, because we're dealing with the only fuel, hydrogen and oxygen. And remember now, hydrogen and oxygen is 4 times more explosive than 4 times more reactive than the world's best explosive. So where the world's best explosive is 30 megajoules per kilogram, hydrogen and oxygen is 120 megajoules per kilogram. And in building this pump, the key is that we don't need a lot of hydrogen and oxygen to be able to control at a very granular rate the amount of work that we want to be able to do. So in general, what we do is we take water, break that into hydrogen and oxygen gas, detonate that in a Mach 4.5 shock wave. It creates superheated steam. Part of that superheated steam towards the end of the cycle is broken down into into additional hydrogen and oxygen gas. That hydrogen and oxygen gas extends the detonation period, and we get more work with less energy, shy of a nuclear bomb over all work processes. So right now, we can move twice the water for the same amount of energy. And where water uses up 1/3 of all the electricity produced on the planet to move water, we can save about half of that. And so if we save 1/2, that's 1/6 of the world's electrical use consumption that we can save. All green technology, can't even get the 10%, and we could sit here and save 1/6, which makes us potentially the greatest green technology that's out there. But in doing that, the pump gives us, in this new work cycle, mastery of pressure, vacuum, and velocity. And when you go and you look at hydrogen in general, the only thing that people suggest on hydrogen is that we're going to use it to drive a fuel cell. So a fuel cell is only 67% efficient on its best day. Okay. And so you're going to have a 67% efficient pump driving an electric motor that can never be over 90% because of Lenz's law. And then you're going to drive another pump, or a mechanical pump, which is about 60% efficient. So you got three inefficiencies to be able to drive a pump. And in this, we end up with a super efficient pump in the high 90s that gives us both pressure and vacuum. And Subhash and I have talked many hours about how this could change everything in the oil and gas industry, because we add both pressure and vacuum to be able to completely change how we recover oil. And when we start looking at this, we can do what's called low pressure flash distillation. So the pulse detonation pump, we can get down to 2 psi easily. And as we bump up the pressure, we can actually get to lower vacuum. When we go to rotary detonation, we can get to less than 1/2 psi. And at 1/2 psi, that means that we can boil water at 86 degrees. So we can completely, in the same energy footprint of moving water, flash distill it into distilled water, moving that into a pipeline, being able to set the chemistry of that water however we choose it to be, and give ourselves the technology to create water superhighways.
All right, that sounds great, Van. So now, why don't you tell us the status of your prototype? You know, what you're doing and when it's coming, and what's the challenges, Vance?
Okay, so we've got a working pump, but we're working on fixing the computer. The computer has to control the detonation and have a work. And what we did is we set out to build a industrial controller SCADA system to drive this pump. And Wago gave us all the industrial controllers. Now, AlleyCat is who we're using AlleyCat mass flow controller. And when we ordered the AlleyCats, we ordered them with TCP/IP. We ordered them with a totalizer. And what happened was they sent us units that could not do the batch. Okay. So that required us to send them back to the factory for them to be retrofitted. So we got them back just about a month ago, and we got them out into the field, and we got the code to be able to open and close them, but they weren't performing correctly. And so we took them back to AlleyCat, because when we did get them working, they were supposed to deliver gas in 1 second, and it was taking 54 seconds to do 2 grams. So that was wrong. So they took it back, and we told them all the problems that we're having. And then they said, oh God, we forgot to set this register. Okay, so they set that register, But then at the same time, they realized that they had undersized the mass flow controllers, which means that they've got to open up the orifices and replace the hardware in those. And there's a lead time of about 30 days.
Sorry, Vance. Sorry, Vance. That's yeah. Can we just get a little bit more? I just really want to understand a couple of points. I understand there's a lot of operational stuff and where it's at. What I really want to understand is from an investment point of view, that's really where I come in. As far as the workings and the IP and building what you need to, we can have that as a separate session. I just want to understand from you today, have you got any investors that have put money into this venture to date?
We've had investors that have put money into this that accounts for about 5% of this.
Oh,
Now,
5% equity. Yeah.
what's that? Yes,
5% equity in the so you've set up a company with shareholding and all of that, and you've given them 5% equity. Is that a debt facility or is that just pure equity?
that was equity, but in a way, okay. So the company was supposed to be formed and the company didn't get formed correctly, but we have
Yeah.
our investors and we are not taking advantage of our investors. Now, I've been talking to the investors and we've been talking about how we give them equity in the company so that the shares would remain in company control so that we don't give a percentage away so that we lose control of the company. But out of the company's revenues, they get the percentage based on the equity that they've been promised. So instead of it being that they own shares, that they are owed the equity value that the company realizes from year to year that have to be paid to them directly.
Okay, so all right. So you've taken a loan from them, have you?
Basically,
A
we've
loan.
taken a loan from them.
A loan, yeah. So it's like a convertible note, really, isn't it?
That's
So
right.
yeah, convertible note. Okay. So okay. How much did you loan from them?
We've taken in about
You
$250,000.
250,000. Okay. All right. So it's not a lot of money. Okay. All right.
We have really we have really busted our ass not to waste money, and and the 250,000 we have taken. When you go back and you look at everything that we've done, it's amazing how much we've gotten done.
Yeah. No, that's great. So have you got a business plan on and what you need as far as funding's concerned? Because you've got a prototype from what I'm hearing, to get it from prototype to the next stage, which is the manufacturing stage. Is that
No,
right? Or
we're working on that right now. So
right.
Nafu putting together the the he's working on the business plan. He's working on the video that'll be in English and Japanese to explain the technology to um, the scientific and business leaders how this actually works. So
And that's
that's
for the purpose of fundraising, right, Vance? For the purpose of fundraising.
That's for the purpose of fundraising. We were
Right.
hoping that the pump was going to be ready. It should have been ready right now where I'm sitting, but we've got the pump back in Tucson, Arizona at Process Control and Engineering. Part of what they're doing right now is they're rewriting the SCADA code in a version of CodeSys that is current. So it had been written in what is called eCockpit, which is Wago's SCADA software, and that's like 3 versions of CodeSys back, and they've since scrapped eCockpit, and so now we're getting while the alley cats are being redone, we're revisiting the code base because we had some issues with that. and a lot of discoveries about how to get all of the sequencing done and all of that. And so we're rewriting the code to accommodate the changes that we've been working on. We do a lot of things to calculate what's going on with the mass flow controllers based on temperature and pressure versus STP, standard temperature and pressure. And then we have to change that per our sensors to what they need to be, because um, uh, intimate control of the hydrogen and oxygen gas that we're delivering. If we make a mistake, we can backfire, but we will never create a real problem. You can't create an explosion when you only make what you need on demand, if that makes sense to you.
Okay. All right. So just back to the funding, how much, just trying to understand. So there's a couple of things I want to just get some traction on, if that's okay. I'll just cut straight to the chase. I guess Bob we've been working on other projects where we look at funding. He mentioned that you guys were looking for funding. I need to just understand where you're at in that process. If you're looking at working with people, if you currently got people, where you're at with that. A little bit
We
about,
do
yeah.
We do have people. Luis Castro is a process control engineer who owns process control and engineering and robotics down in Tucson, Arizona. They also have a shop that's in Leon, Mexico. So he is responsible, and I'm working to continue with him down the road, so that we can give him our business to grow his business in the industrial control sector. We have a guy named Tommy Chappell out in Odessa, Texas, which is a company that's responsible for rebuilding pumps and is in the oil and gas sector. And then Subash online, he's an executive for one of the famous oil companies out there.
Yeah.
So we do have individuals that we are working with. We are literally working out of a shipping container.
I, so these guys, sorry, just so these people are basically part of your team then, yeah?
Exactly.
Yeah, so they're your team and you guys are bootstrapping it yourselves, funding it yourselves, is what you're saying.
That's right.
Yeah. Okay. So
And
what I
and
just
and I'll let Subash talk here in a minute. We talked about what your offer is, and $10 million is attractive. But I want to point out that we've been exceedingly frugal. And from that, I will tell you why that we're this way. When I got started in computers, I worked in Silicon Valley in the early 80s. And an individual that is famous for venture capital in Silicon Valley dragged me to a number of companies out there and was exceedingly frugal and drove home that no business succeeds that doesn't follow some of the rules that he taught me. And I've taken that to heart. And Subash knows that we try as hard as we can not to let money go, not to waste money that's coming in the
yeah,
front door, and not let
yeah.
it go wandered out the back door.
Yeah, so I guess the real thing is a couple of things. We look, I've got people I could go to. I've got one in particular. He already owns a pump. It just so happens he owns a pump company already today, and they're doing 100 million in revenue annualized. Um, I could go and take it to them potentially, and get them to potentially fund it. But what we need is the basics of doing a proper, fundraising, venture capital, which all comes down to the business plan. How much, you're saying a number 10 million. Well, where did you get the 10 million from? I need some understanding of how that goes. I've signed an NDA with Bob. Obviously, we should do a 3 or 4 or 5 party NDA. More than happy to do all of that. I guess we in the business of bringing money together. But if I just want to understand, if you're dealing with people, then I'll let you deal with them. If you're not dealing with anyone, then we're open to having those discussions with you. And that's really where we're at with it. In terms of money, $10 million is not a lot of money. I'll be honest, I was saying to Bob, you know, it sometimes that could be a bit too small on the money, but it's not like, well, hey, let's charge 20, 30, 40, 50 million. But sometimes it's easier to get the bigger end of money than it is the smaller, believe it or not, for whatever.
Well, I recognize that, and I'm trying to be sensitive to that. And at the same time that I'm trying to stay within my frugal lines, because if you go back and you look at the projects in Fortune 100 companies that I've done, my projects always outperform what was expected. I'm still working on that. And,
Yeah.
Subhash and I have talked many hours about this. And when it comes down to money, Subhash, would you introduce yourself and kind of take over from here? Because I can talk about the technology all day, but I'm kind of beholden to Subhash, who's a lot wiser on that financial side.
All right. Okay. So he's the finance guy.
Yeah, thank you. Vance, good and appreciate your time. And Bob, thanks for setting this up.
Yes, go
Yeah,
ahead.
so we are from the technology side, like Vance mentioned, it's been coming in a good shape, but we are still in the final stage of doing the final stage of testing. That means the controller is where the challenge is. They are in the final stage of retuning. So hopefully we get it within the next 2-3 weeks and we'll be able to test it. Application wise, we are seeing in multiple areas. One of the things I have a heavy background in oil and gas industry. So what I'm seeing is it could be a game changer or revolutionizing a lot of things in the oil and gas industry, especially subsea pumping. I deal with a lot of subsea pumps. So subsea pumping or even the artificial lift system. It's a multi-billion-dollar industry every year. And there is not new technologies, forever. So there is one other area there we wanted to pilot some of the verticals along those lines. Getting back into the financials, what Vance mentioned was, yeah, there are a few people who has helped with the initial setup and come to this stage, but there is no commitment as said. There have been some verbal commitment up to like a 5% total. But the objective here is we want to listen to what your background is, what you guys are offering, because without understanding the products and the complete application, it's also hard to wrap the head around it, right? Like to get a clear idea on what we are looking for. So from my standpoint, what we are looking for in terms of initially to take the product to the finish line and then see where, we haven't really committed to any of the bigger players. Let me put it that way. So I wanted to test the pump before we go to the next stage. I know Vance has mentioned about Bob several times to me. So when this came up, I would like to see what do you guys foresee. I want you guys to understand about the product more, Gordon, before we talk about the next step, right? That's what I think it should be coming from both ends. I don't think we are in a position where we would say, oh, this is what we are looking at this point, especially once you probably understanding the potential of the product, maybe help us take it to the finish line. And then from there, it could be that's what I would expect.
Yeah. Look, I mean, they're all very good questions. So I guess, what we're talking about here is VC space, venture capital. So part of what I do, and I'll just talk a little bit about myself for a minute. On my day-to-day grind, as we call it, is I'm a business broker and a business valuer. I value companies from 1 million up to 100 million. I value them and I sell them. Okay, that's what I do day in, day out. The areas I work in is technology, mining, energy, mine remediation, and resources. Those are the main areas I work in. The other part of it, I had my own company for 6 years doing M&A VC, mainly venture capital, where we focused mainly on startup companies, raising capital for them. I'm still involved in that business, although I've got someone else running that business for me. I'm an owner and shareholder of about 4 different companies. One of them is an international company which is in the small modular reactor space, which is nuclear reactors, and bringing them to the world. And that's how I know Bob. We kind of working on projects together in that space, and also the fuel and manufacturing the fuel in that area as well. So I'm also involved in other projects in fertilization and so forth. But I guess for my aspect, the engineering space, I've got a lot of contacts in the mining, especially in the aluminium mining, bauxite, rare earth minerals. Some of my clients are huge publicly listed companies looking to invest money in, well, buying companies. They buy companies. That's what they do. It's all mergers. So would they look at something, a VC thing like this? If it's got to do with the pump, I mean, let's be honest, there's the combustible engine and then there's pumps, right? So if it's good as it sounds, I'm sure there'll be a lot of companies that would look at it. Obviously, you're at the VC space, so you're right at the beginning, you're busy bootstrapping, and you're looking at seed funding and then going series A, B, and C. You get different funders for different stages in funding cycle. What I would say is I wouldn't go, as I said to Bob, it's not a matter of, well, let's go in for 50 million off the cuff. What I would say, it's probably better to find someone that can come in nice, like around the 5-10 million mark, and they get paid in tranches anyway, but more of a sophisticated type of investor that is smart money, people that have expertise in engineering, that understand the value, that are willing to part with the money, but also give you the resources that you need and the contacts that you need in order to take this not only where you are in the US, but potentially to the world. So there's all these things. Unfortunately, you're gonna get to the point where you're gonna need to make a decision on the IP and where that sits. Obviously, wherever you are, that's where the IP is. So I do have American investors as well. I've got an international portfolio of investors. So generally, investors like to invest where they are. That makes sense. And every now and again, there's cross-border investments as well. So that's really what I do and what I'm able to bring to the table. As far as next steps, which really it really comes down to understanding who the shareholders are in the business, and have you guys got any sort of idea on company formation, all of that? That's all things that I specialize in, is company formation, structuring, everything from the beginning right the way up. If you're in America, I'll be honest, it's your rules are slightly different to ours, but at the end of the day, very similar. I'd probably want to just understand a little bit more about how that all works. For example, if I had to bring you an Australian investor, for example, would you be prepared to host, or would you be prepared to come to Australia to build your prototype or complete your first of a kind, your FAK, or build your demo, or do you want to remain in the US? There's all these types of questions before we can really move forward on anything. I need to understand that who the investors are. If that's a loan, it's a convertible nodal, it's just alone, it's very small. And what you need and the journey ahead. I think the most important part is the willingness. Really, the topography is key here.
Well, Gordon, let me clarify a couple of things to you, okay? You know, it there are times that I just want to stop and I want to retire and just throw this idea out the window. But this is not just this is not just an idea, and this is not just a pump. So when you look at any electrical generation plant, they have a steam plant on that. When you look at the work cycle of that steam plant, you will see that this pump is actually a new work cycle to replace all of the steam plants that are out there. A steam
Yeah,
plant has to cool the water down to get its vacuum. But because we're using hydrogen oxygen, that gives us our vacuum well. Okay. We have Mach 4.5 velocity to be able to drive the steam pressure and velocity up. When you start looking at the patent that we have, when we filed the patent, the patent office said, "Hey, Vance, on this apparatus patent, you're going to have to pick one apparatus." So my patent attorney is a guy named John Peck, and John has his PhD in both chemistry and physics from Caltech, and he said, "Vance, we need to change this patent to a process patent." So we have a process patent for the world's most efficient work cycle. So when you start thinking about nuclear reactors, why do nuclear reactors fail? Because they lose their cooling. When they lose their cooling, they end up making hydrogen and oxygen gas. That hydrogen and oxygen gas becomes the fuel necessary to drive this pump so that they don't overheat anymore. It is the pump of last resort in the nuclear industry. It is replacing the steam cycle on every electrical generation plant. Whether you're going to do fusion or anything else, you need to convert that into pressure. And this is how you do it. So by the time people start figuring out this is more than a pump, and we're just
mm,
trying to stay, we know how big the picture is. Getting
yeah,
everybody else to figure out how big the picture is, because this is the workhorse for the future. This is how hydrogen actually fits the model in the future. Now,
yeah.
Subash will tell you it's taken him over a year. He comes back to me and says, "My God, Vance, we can do this. My God, Vance, we can do this." And I said, "Yep." And he goes, "Why didn't you tell me?" I said, "I just got to get you in the little box first and then expand on that." So unlike Sabash, you're now in that first box and we're trying to bring you along. So, when you start thinking about what it is that we're offering you, and that's why Sabash is saying we've got to start with a little bit of money and just get our our prototype running so that people see this working. When you see it working, and then we start explaining all the rest of this, it's going to blow everybody's minds. Why, for 150 years, nobody caught the relationship? And in this relationship, the thing that everybody misses, when you detonate hydrogen and oxygen gas, that temperature is 5,100 degrees. That 5,100 degrees is hot enough to break water molecules into additional hydrogen and oxygen gas. It does it in a logarithmic function. It's not linear. So that means that the bigger we make our detonations, the more boost we get. So nothing in this world gives you more work the bigger you make it, except this. And it doesn't violate, it's not over unity. It is driving the Gibbs free energy down so that we've used the temperature, we've used the pressure, we've used the vacuum. All of them work together as this elegant symphony to do work. And that was missed by everybody. It's only within the last few years that they've realized that thermolysis was going on when they did atomic blast that was giving them overpressure. And that's been bothering people because, nobody's ever looked at when you do hydrogen oxygen detonations, is there a thermolysis that's going on? And everybody that we talk to, when they sit down and they do the math, they're sitting here, yeah, it's there. Is it logarithmic? They go, it's not linear. We know it's not linear. It's logarithmic. So, we're starting out with 2 grams that's giving us like 45 psi. When we move up to 5 grams, we're up to about 1,000 psi because we get that boost.
That's gram of hydrogen, right? Grams of
That's
hydrogens.
right. So when Fukushima blew up, they didn't calculate on the thermolysis sitting here driving their pressures higher than what they expected, but they got a hypersonic detonation out of that.
And this does not violate the thermodynamics law, the first one and the second one, right?
No,
Vance?
it doesn't. It is an efficient way to drive Gibbs free negative.
All
That
right.
thermal temperature that was in there broke bonds. Okay. By the time that the shock wave gets to where that hydrogen and oxygen is towards the end of the shock wave, because that's down there at the surface of the water, by the time that the shock wave travels to the surface of the water, that's just extending the detonation out a few milliseconds longer. So we got more work done.
All right, Vance, Subhas, I think we need to conclude here
Yeah.
the discussion.
Yeah.
I figured that Gordon need a business plan. I already give him the summary of your technology and my opinion of your technology, and it has huge revolutionary potential. Billions of dollars of revenue. I mean, I'm quite sure of that. But I think Gordon, to pursue this, needs to have a business plan. Let's say how what kind of if you get like this $5 or $10 million, what, how do you use it, right? And then what's the terms, what are the progressions, right?
Yeah.
My question is, have you done that? Do you have a business plan, Subhas or Vance? Go ahead.
There have been many business plans along the development path that have basically gone out the window. And right now we were just focused on getting the prototype finished within the modest budget that we have so that we can get to that stage. But
All right.
if we have to sit down, Sabash and Bob and Nafumi and the other people that are here, we can sit there and work on that business plan. We
All right.
are trying to do elements of that so that they are ready.
All right. So basically, what are you saying? You don't have an actual business plan how to spend that $5 or $10 million, right? So
Absolutely not. And to be quite honest with you, we're looking for that person that's willing to understand that we're not looking for the 10 million right up front. We're
Right, I
looking
understand.
for we're looking for a small amount of money and a location. I'm doing this out of I'm having to move the pump from place to place to be able to get pieces done because I don't have a formal facility somewhere and I don't have a formal workforce that's working with me. It's
All
just,
right.
partners that we have. But we
Fantastic.
could use that. And we don't need $1 million to get part of that done, let
All right.
alone 10 million.
So can I propose something here? So why don't we work together here and to come up with the business plan that Vance, I trust him very much. He's a very competent person in his field, which is fundraising, and develop together a business plan, right? That on that amount of money, and then so then I'm going to Australia on the 9th. So hopefully by that time, I can discuss with Gordon face to face on the business plan. And hopefully by the end of the year, your prototype should be kind of working, right, Vance? So if
Exactly.
Right. So I'm planning, right, again, as I mentioned to you months ago, that I'm planning to go to the US by the end of the year. So if that suit Gordon, I mean, I think you should also come and see the prototype running. Once Vance already have the prototype running and see that, and then take it from there. So by the time we go there, Gordon, I propose that we already have kind of a business plan, that you already spoken to some people, and then over there in the US we can face to face and get something in writings, get it on. So by next year, early next year, hopefully Gordon has get everything funded. How's that sound? I mean, generally speaking.
Look, yeah,
Yes,
so
and I'm not, we are in the United States. It would be easier to do some of our development work here because,
Yes.
I was trying to do a lot of things in Odessa, but, without a formal facility in Odessa, that was a little trying. So, we're
Odessa in Russia?
in, no, in Texas, Odessa, Texas.
Okay. All right.
So we're we having a formal place to be able to do this development work is fine by me. And if that has to be down there in Australia or Indonesia, I know, when you
I've
start
got a
thinking
friend's
about
place you can use in Mississippi if you want.
Really? You have a
Yeah.
visit? Okay.
Yeah,
there
one
you
of
go.
my best friend who lives in Mississippi, he flies choppers for one of the biggest gas companies in America, taking the crew backwards and forwards.
Well,
On the oil rigs,
that's
you know
not
the oil rigs? He's
that
the
that could
main
work
guy.
because it's not that far from Houston. Sabash
Well,
is down there in Houston.
mate, he's farm. He's got a huge amount of acreage there. He calls it the outback because he's an Aussie and he moved to the States.
Yeah, but I'm just telling you,
You
I'm
need a
a like
warehouse.
a I'm like a clean freak. So unless he's got a shop that's like white on the inside and completely sterile for me to do work and not blow anything up, I
Yeah,
hate working out of I hate working out of, a facility that just doesn't match the electronics and the clean room and all the
yeah.
stuff that we're trying to do.
All right. Well, we'll have to put our heads together and see what comes up. But if we get the money, you can rent one.
Yeah.
Well, that's the point. Where
Yeah.
do I do that? I'm
So
willing to do that as long as I've got the place. I'm willing to do it anywhere. You know.
yeah. Okay. Well, look. Let's look. You need money. You've got some plans. If you can just maybe put some numbers down, what it's going to cost for the rent, what you need from a money funding perspective. Um, just keep it high level, and then share that with us. We'll knock up Bob will get a NDA happening between all
Mm.
of us, I'm sure.
Yep, I
Um,
will.
and yeah, we can work on a business plan with you. Bob and I, we do business plans in our sleep. So we'd be happy to help out there. Obviously, we need your subject matter expertise to put it in there. And Shubash, I'm sure he's done many of them in his day. So between us, we can put something together. But at the end of the day, in order to just bring some money to the table, I need some sort of fundamentals of what we're trying to achieve.
Yeah.
And we're willing to work on that.
All
Beautiful.
right. All right. So I tell you what. So I'll draft something, a three ways NDA within all of us, right? And I hope within this week everybody can sign, so then we can start sharing data and
Yeah.
informations and develop some kind of
Yeah.
basic business proposal, right? Basic business plan, just the basic one, and we'll take it from there. Sound good?
Yeah,
And
Gordon, I just need to drive this home, okay? When you start thinking about the applications, we've got Nafumi that I'm driving over to Nafumi's right now. I'm just
right.
about a mile away from where he's at. And so he was looking at Japan and talking to his friend that's the president of Sumitomo Bank. And they
Mhm.
were calculating out how much energy cost goes into the water facilities within Japan. And then they came up with the number that if this saved half, they looked at the number and, that's like just shy of a couple few $100 billion a year. And so that's why I was sitting here to Nafumi. I said, how much of the, Nafumi wants to help us in Japan, and he has a lot of business connections in Japan. So with Sumitomo Bank, they bought into Sumitomo Metals. They have connection to Nippon Steel now. Nippon Steel has bought U.S. Steel, so that gives us our alloys that we're going to need to be able to build these high pressure pumps that we want to build, and all the things that go along with that. And the numbers of what this pump and the revenue streams that can come out of this are mind
Yeah.
boggling. And we're
Yeah,
just
Yep.
trying to, we got 100 years to drive this thing.
right.
I keep telling, I told Sabash, it's like, this is, Henry Ford in a Model A or a Model T Ford. And it was just the beginning. And everybody wants air conditioning on it right from the get-go. So, we got a lot, this thing has a lot of legs for a long time to run.
Right. Okay, Vance. So I guess we agree that we sign something NDA and then work together on the basic proposal. And hopefully, I target to come to the US by the end of the year, maybe December or January. So hopefully, Gordon will come, right, Gordon, and meet you face to face and get this deal through. So Gordon,
Okay.
last word from you. You're confident. How confident are you raising the fund for this technology?
Well, I mean, the funding's it's not that difficult. It's going to come down to how convincing we are with regard to how far they are in delivering the actual the prototype, really.
Sure.
So that's really what it comes down to. If there is no working, you said 2 weeks, Subash said 2 weeks, Van said 2 weeks. So if you can have a working demo that's working, a miniaturized version of it, you can get money anywhere. You
So
can get money anywhere.
that's the plan, Gordon, because we are
Yeah,
waiting on dependent right now on the third party, because they are calibrating and recalibrating the control equipments. Once that is done, they have promised 3 weeks. So hopefully 1 week have passed by
oh,
already. So we should
yeah,
get it.
yeah.
And yeah, you're
So,
right. That
so,
then we can
so
there will be a
that's
lot
it.
of things to tackle by the time you guys are here.
I'll tell you very quickly. I've got investors that would take. I've got many investors that would take this, but I've got one in particular. They're actually American, and but they also invest in Australia. But they support anything that is saving energy, anything around the green energy, and that's what this is, right?
Right.
Oh
That's right.
God, yes.
And
Definitely.
they got 500 million that we could tap into. So I mean, and they're based in the US as well. So what I'd like to do is let's get the NDAs and everything. We need a very high level, put it in one doc. I'm more than happy to tell you. I'll come back to you very quickly on how the arrangements and so forth. I'm happy
Right.
to, and yeah, I'll be able to fund this very quickly, very
Okay.
quickly.
Very good. Very good.
Yeah.
So
All right.
okay. So I guess that's let's wrap it up. I think guess that's the follow up,
Well,
right?
well,
Vance, last
let me ask one thing. Sabash, is there anything you want to say before this conversation ends? Or are you good?
I mean,
No,
it's
I'm
yeah,
good, Vance. I'm good. Thank you. No,
Okay.
yeah,
Okay.
it's very clear, right? So that's a like we
yeah.
Yep.
discussed when the pump is almost tested. It's a good way to have conversation. Then we can go into depth, right? Like
right. That's
Gordon
right.
with Bob,
Yeah.
we can have much
So
more detailed conversation. Yeah.
I
right.
had one question before
Go ahead.
everyone goes. I mean, we obviously can speak at any given time, weekly, fortnightly, whatever. But as far as the shareholders are concerned, how much equity are you willing to relinquish?
Yeah.
We
Important questions.
do not, yeah, we're sensitive to that, but we don't want to give up. It's important that we don't give up control of the company and that
Okay.
there is a
Yeah.
poison pill on the intellectual property. You really, we when we sit down and we look at the patent and what this represents, when you start seeing the total possibilities. I mean, if you want to drive cars, if you want to drive industry, if you want to drive anything, this is the engine that will efficiently do that. And so, we have to be prepared to be prudent with the intellectual property. And there are a number of great people that have said, Vance, you are the caretaker of this IP. You have to protect it at all costs. And it's
Yeah.
not because I want to just be some rich dude. Okay. It, my responsibility is how we provide energy and water to the future most efficiently. And that's the only reason God keeps me hanging around.
Right.
Yeah.
I'm serious about that.
Yeah. Yeah. No, that's good.
All
That's
right,
good.
guys.
All right. Wonderful. So,
I think
so
we're
just to, sorry, Bob. Yeah. So
yes,
on
go ahead.
that, so just to cover it off, look, if you guys are as close as you say you are, 2 weeks, um,
I'm going to say,
I mean,
okay, I've had a lot of roadblocks thrown up in my way on this, especially on the industrial controller. My engineer got sent to some mine down in Mexico and he was offline for a month. And so, you know, process, would I like to have somebody else that I can go to right now that I'm paying good money to so that they're there every single day, like clockwork, finishing all this stuff up? Absolutely, yes. But I don't have the money to do that. And Luis, out of the kindness of his heart, is helping us do this project. When you look at the people that are working on this that believe in me and what they are giving me, there is so much that is being given to me that, I can't, I have plans to be able to reward everyone that is helping me. And, I need to at least get you on board with that. So you at least, what we're working on and who
All
we
right.
are character wise.
So
yeah,
I guess
no,
let's take it about a month or two maximum. Then prototype should be ready, Gordon. I think that's
yeah,
the
yeah.
take.
Okay. Well, you
Yeah.
guys, yeah, so that's fine. Well, let's get the NDAs finalized and we'll start working towards a bit of a plan and structuring how we can work things on that.
So
Okay.
Perfect.
last question, funds to you. So you are in the process of making that video to raise funds. So what is the immediate funds
Yeah.
needs that you are hoping to get?
Uh, it's, it's like the business plan. Nafumi is working on what he needs to do to have, there is interest, like I said, from the president of Sumitomo Bank and Sumitomo Metals. And uh, I'm hold on. You're a little close. Yeah.
Okay.
So he's working on that. He's going to do this in Japanese and English, and
Right.
it should work with with the business plan that we're putting together. This is a professional. We're working with getting multiphysics software to do the software to show the animation that the computer simulation will show for these pumps and the potential that is rooted in physics. So this isn't just, some feel good video that we're putting together.
All right. So what kind of funding, immediate, urgent needs that you need to have to finish these prototypes currently?
Well, Subhash, what do you think? What would be a fair ask?
You're
Are you there,
muted.
Subhash?
About $100,000.
$100,000.
I
Okay.
would agree with that. We're not looking for a lot of money.
Vance,
could
maybe
share-
maybe shared any pictures? Please share some pictures to Bob so that he knows what we're talking about. At least the
Yeah.
equipments.
Yeah,
Okay.
I can
Want
do
to
that.
share pictures? Okay, go ahead.
But I
I'm gonna
can't.
go ahead.
I will do that over the days. Okay.
Yeah, I'm
I
gonna
will
have to
email
run.
them back. If we can get you guys on an email list, I'll add you onto that too, Gordon.
Yeah,
All right.
wonderful. Guys, nice meeting you. I gotta run. I
All
gotta
right.
jump into another
Okay,
meeting.
guys.
Nice
Let's
meeting you,
communicate
guys.
by email. Thank you very much, Vance, Sebastian,
Yep.
Gordon.
See you
Bye-bye
guys.
now.
Thank you very much.
Thank you.
And thank
Take care.
you very much, Bob. Thank
All
you,
right.
Gordon and
Nice
Bob.
meeting
Thank
you
you
guys.
for doing all
See
this
ya.
together. Okay.
Bye-bye.
Good night.
See ya.
Bye.